What's up guys, we're going to be taking a look at this lab, Broken Brute Force Protection IP Block. So as suggested in the title, this lab does have brute force protection in the form of an IP block. If we input the incorrect username and password a certain number of times in a row, then our IP address will be blacklisted. We won't be able to attempt to log in again. There is a flaw in the way that the brute force protection works, which is the counter for how many failed logins we've made is reset every time we make a valid login. So the basic idea here is we can still brute force the login for this lab, provided we intersperse our brute force login attempts with valid logins using our own credentials, Wiener Peter. Okay, without further ado, let's access the lab. The first thing that we're going to do is attempt to log in with invalid credentials. So let's click the My Account option. Let's choose the username Carlos. So we already have a valid username in this case. We don't need to enumerate that. And let's just use the password, and let's capture this request with Burp proxy. So here is a copy of the invalid login attempt. We can see that as part of the post body, we have username Carlos and password equals password. The first step is to insert payload markers around the username and also the password, since this is what we are attempting to brute force. So the way that this is going to work, we're going to make an attempt at guessing the password, making use of a word list provided by Portswigger. Then when that fails, we're going to post a valid login attempt. Then we can try again with the next password in the list. So the attack type we need here is pitchfork. This is going to try the username Carlos along with a password from the word list. Then the username Wiener with the known password Peter, then back again to Carlos with the next password from the password list. The tricky thing here is actually setting up the word lists. So we can see here we need two word lists. For payload position 1, we need a word list that iterates between Carlos and Wiener. And for the password, we need a list of passwords provided by Portswigger, but interspersed within that list, every second password needs to be the valid password for the user Wiener. So for this attack to be successful, we essentially need custom word lists. Now I assume the go-to way to do this in the industry, possibly using something like Python or potentially even Bash. I'm guessing that you could even achieve similar results perhaps using a spreadsheet such as Excel, for example. It's not 100% straightforward to generate these lists. We're going to see an example of how we can generate the two word lists we need, making use of node.js. So we're in an empty directory with the title Burp, and you can see in this directory we have wordlist.txt. And if we just echo this to the screen, this is the Portswigger word list of passwords, which we'll need shortly. The first thing we need to do is actually create a list of usernames. So what we'll do is we'll create a new file and we're going to call it usernames.js. So this is going to be a node.js file. First thing we need to do is call in the file system module with node. So we'll say const fs equals require fs. And we're then going to define a variable which we'll call content. This is basically going to be the content of the text document that we're going to create. So we're going to make use of a for loop in Node.js. So we're going to say for let I equals 0. So I is going to be our iterator in this case. And we're going to continue iterating so long as I is smaller than 101. And at the end of each loop, we're going to increment I by 1, which we can achieve using I++. We're then going to define our block of code. Okay, so inside our loop here, we're going to append to content with content plus equals. We're going to first of all add the username Wiener, which is going to be valid. We're then going to include a new line character, which is \n. We're going to end our string. We're going to make use of a semicolon to terminate the line. Then, as part of the same loop, we're going to append a second time to content. This time we are going to append Carlos. We're going to make use of a new line character again. And that is now the end of this loop. What we have at this stage is the variable content, which is a string that iterates between Wiener and Carlos. And we simply want to write that string to the file. And that string also makes use of new line characters. Every time the string contains \n, the text document is going to write to a new line. So you can make use of fs, which is the module that we imported, fs write file. And this takes a few arguments. First of all, we want to specify the name of the text file we're going to create. We'll just call it usernames.txt. Next argument is going to be our content variable. Now, depending on the version of Node, you will need a callback function here. That callback function is going to take error as a parameter And we're simply going to console.error the error to the screen. So we'll say if error console.error, pretty similar to console.log, but specifically for errors. We're going to console.error the error. We're then going to close that if block of code. Finally, we need a trailing right bracket to close the .write file method. Let's call node on usernames.js. Let's have a look at our directory. We can now see usernames.txt. Let's cat usernames.txt to the screen. And you can see we have an iteration between the user Carlos and Wiener. Now we do actually have an undefined at the beginning of the text document. This is not really a big problem. We can just delete that manually. If you are wondering why that happened, if we take a look at the code again in usernames.js, when we have this line content plus equals, this means content equals content plus Wiener, but content doesn't have a value at this stage. Now we could get around that by assigning an initial value to content. Then we can make use of content plus equals. But the easiest thing to do is possibly just delete the undefined from the top of the text document. So for example, if we vim into usernames.txt, all we have to do is delete undefined from the top of the document. And we now have a word list that iterates between Carlos and Wiener. The next task is to create a similar word list. We already have the word list from Portswigger. This is a list of passwords, one of which is going to be valid for the username Carlos. But we know we need to intersperse this with the valid password Peter for every second password because we want a valid login. So this is going to be similar, slightly more complex. Let's once again start by creating a new text document or a new JavaScript document. We're going to be calling it passwords.js. And once again, we're going to start by importing the file system module. We're going to need a second module this time, which is going to be readline. So in the previous script, we were just writing to a document, whereas in this case, we actually need to read from the Portswigger password list in order to construct this document. So we're also going to import the module readline. Now, quick note here from future Zen shell, this second line is incorrect. Should be const readline equals require readline. But you'll see I figured that out towards the end when the script doesn't work. But you'll also see me making use of a readline variable. That's because the second line of code should be const readline equals require readline. Now we always have to be a little bit careful when we are reading from a file. There's typically a right way and a wrong way in terms of performance. The wrong way is to load the entire file into the buffer before processing it. The more performant way is to actually create a file stream and read that file line by line. Doesn't really make a big difference for a file this size, but if you are dealing with files that are gigabytes in size, then we don't want to load the whole file before we begin processing. So we'll say const file stream equals, and this is built into the FS module, create read stream, and we are going to pass the text document wordlist.txt, which is in the current directory. We then create an interface and we provide this file stream as an input. So we'll say const rl equals readline.create interface, and then we're going to pass a configuration object to create interface. This is going to be a fairly bare bones configuration option. All we're doing is defining the input in this case, and the input for this interface is going to be the file stream, which is reading from wordlist.txt. That's it, configuration option complete. We then want to create an asynchronous function. Part of the reason why this is asynchronous is that it technically takes time to read lines from a file. It may be a very quick operation, but the idea is the data is not all present to be operated on until it's been streamed from the file, which is why we need to make use of an asynchronous function. So in Node, async function, let's call it process lines, and we'll call the function afterwards. Now I will define my content variable here inside the async function. So we'll say let content equals, I think this time we will actually start with an initial string so we don't get that undefined at the beginning of the text document. So we're going to start with a valid password in this case, which is going to be Peter followed by a new line. Then the idea is every second password will be one from the Portswigger word list. So remember that our file stream interface is under the constant RL. So we'll say for await. Now await is used because this is an asynchronous function. For await const line of RL, the interface. So now we can access line by line the contents of the wordlist.txt document. We can say content plus equals line. So when we say line, it refers to a single line from the Portswigger password list. And we also need to append to that a new line character. And of course, since we need 2 lines for each loop, The second line is always going to be the valid password for the user account wiener, which is going to be Peter, followed by a new line character. And at the end of this asynchronous function, after we've read all of the lines, we're simply going to return content. We can then write that to a file. So we know that we've defined this function process lines. We can call process lines. And because it's an asynchronous function, it's going to return a promise. Without going into too much detail, means that we can call the then method on process lines. Process lines dot then we can take the response data. So we'll pass this as the parameter res for response. So this is really content at this stage. In fact, we could even just call it content rather than res. This is just a convention to refer to this as res as the response, but it's not that important. We're then going to make use of writefile, which we saw in the previous script, fs.writefile. We're going to create a file. We'll call it passwords.txt. The content is going to be res, which is the value that's returned from the process lines function. Then as mentioned, depending on the version of Node, we will actually need a callback function for error handling. Let's write that. It can just be something very simple. In fact, it doesn't technically need to do anything, but it would usually have something like if error, then console.error. Then we make sure we have our trailing close right parentheses. In fact, we're going to need two sets of trailing close right parentheses in this case. All right, so everything looks good here. Let's write and quit that from Vim. We're now going to run node passwords.js. Okay, looks like there's a small error in passwords.js. For some reason, I imported readline but used const fs again, which is actually incorrect in this case. So we just want to change that to readline, it should be called. So it should be const readline equals require readline. Not sure how that ended up that way. Okay, let's try that again. Node passwords.js. Let's have a look at the directory. So we have a passwords.txt. Let's inspect the contents of passwords.txt. So you can see that we have the word list from Portswigger. We start with a valid password. We then have the first password from the Portswigger password list. Then we have the valid password again. Then we have the next password from the Portswigger password list. So we're actually starting with a valid password here. And if we also cat the usernames.txt to the screen, hopefully we are starting with wiener. So we start with wiener, we start with a valid password, which is probably unnecessary. We could actually just start with the first attack. Now, of course, at this stage, I had totally timed out from the lab. So in the background, I just spun up a new instance of the lab, had to find a new request and then reset the payload positions. So let's think about our two payload markers now, and let's add the appropriate list. So payload position 1 is going to be the username. So it's really just a case of copying these from the text document and pasting them. Let's head to payload set 2, which is going to be our password list. Once again, let's copy from passwords.txt. Let's choose the paste option in Burp. Now, it's very important that the order of these lists is maintained because we want to make sure that every second login attempt is valid. In fact, you don't technically need to do every second login attempt is valid. It could actually be every third login attempt. So you could actually modify the word lists to reflect that. Now, because it's not guaranteed that the order is maintained, Intruder is going to send out the HTTP requests very quickly. We can create a new resource pool. We'll just call it Burp. The important option here is maximum concurrent requests 1. This means that the order will definitely be maintained. So by only sending one request at a time, we can ensure that our login attempts are sent to the server in the correct order. Okay, with our new resource pool selected, we can now choose Start Attack. So we can see the attack in place, and we can see that every second request is Wiener Peter, followed by Carlos, and then one of the passwords from the password list. So everything seems to be good at this stage. Now you can see for valid login requests, we get status code 302, the redirect. And of course, every second request is going to be valid. What we're interested in is a request where the payload is not Wiener, it's actually Carlos, but we still get a 302 response. By the way, the easiest way of doing this is to first of all sort by status code. We get the 302 responses at the top and then sort by payload 1. And you can see the first result here is Carlos with the password Michael, and we get 302 response. Now we're only at 75 of 200 requests. This will get increasingly slower as it goes on. We don't really need to continue the attack because we have a valid username and password, Carlos Michael. So at this stage, we can stop the attack. The objective of this lab is simply to log in. So username Carlos, password Michael. Let's choose login. As you can see, some issues with the actual request. Let's try that again in a fresh tab. Great, we've logged in. Congratulations, you solved the lab. I would say a couple of key takeaways here. First important takeaway is that although there is brute force protection in place, the counter for invalid logins is actually reset every time we make a valid login attempt. So this is something that you could check for when experimenting with brute force protection on a certain web page. Second takeaway is it's fairly useful to have the ability to write some custom scripts. Maybe you found a different way of creating the word lists. Maybe it's even more efficient than what we looked at in the lab today. If so, feel free to let us know in the comments how you were able to create the word lists. There was also a mention of a plugin that you can get for Burp as well. It's called Turbo Intruder, and I believe that's customizable, making use of Python. But of course, you don't actually need the plugin. You could just write a Python script to generate these word lists. All right, that's pretty much it for this lab. Hopefully you found it helpful. Thanks for checking out the content, and I'll catch you guys in the next lab.